Hello everyone. Welcome to the solution of LeetCode problem 448 named Find All Numbers Disappeared in an Array. In this program, we are given a array nums of n integers where each of the array element is in the range of 1 to n. Now we have to return an array of all the integers in the range 1 to n that do not appear in the input array. In the first example, we can see that the array contains 4, 3, 2, 7, 8, 2, 3, and 1. So there are 8 elements. So for each of the element 1 to 8, we can see that only the element 5 and 6 is missing here. So here we have to return 5 and 6. In the second example, the array contains 2 elements, which is 1 and 1. So here the element 2 is missing from range of 1 to 2. So here we have to return 2. So I hope you understood the problem statement and the examples. Now the constraint are here the array length can be in between 1 to 10 to the power 5, and each of the array element can be in between 1 to n, where n is the length of the array. And there is a follow-up questions, which is, could you do it without using extra spaces and big O of an runtime? And you may assume the return list does not count as extra spaces. Yes, we will gonna solve this problem by using big O of n runtime and without using any of the extra space. I hope you understood the problem statement. Now let's move on to the algorithm. Now, for the simplicity of the algorithm, we have taken the first example. Here, this array has 8 elements, which is 4, 3, 2, 7, 8, 2, 3, and 1. So here, in this problem, we have to return the list of the numbers which is not presented in this array in 1 to 8 range. So here we can see that the array element 5 and 6 is absent in this array. This 5 and 6 comes from this range and it is absent in this given input array. So in this problem, we have to return 5, 6. Now, how can we solve this problem using big O of 1 extra spaces or using constant extra spaces? So the algorithm is pretty simple. We will run a loop from left to right. That means we will iterate the array from left to right. Suppose currently we found the first element is 4. So we will make negative the element presented in the index 4. So here we will make 7 negative. Now for this element 3, we will make the element negative which is presented at this index, which is 3. So now for this element 2, we will make negative the element presented at index 2. So here we will make the 3 negative. It is presented at the index 2. Now for this element 7, we will make negative the element presented at index 7. For the element 8, we will make negative the element presented in the 8 index. For the element 2, we will make negative the element presented in the second index, but here 3 is already negative, so we don't have to do anything here. Now, for this element 3, we have to make the element presented in the index number 3 negative. So here 2 is already negative, so we don't have to do anything here. Now for this last element 1, we have to make the element presented at index number 1 negative. So we will make this -4. Now we have modified our input array. So here we can see that sum of the numbers is positive till now, and the rest of the numbers are negative. So if we notice that the first positive number is 8, which has index number of 5, and the second positive number is 2, which has the index number of 6. So here we can say that the element 5 and 6 is absent in the input array. So after making all of the corresponding element negative, we will run a loop from left to right, and if we check whether our current element is positive or not, if our current element is positive, that means we have to append the corresponding index number to the resultant array. I hope you understood the algorithm, which runs in big O of n time according to the follow-up question of the problem statement. Now let's move on to the code. In this problem, the code is pretty simple. At first, we are given a function, find disappeared numbers, which is a array parameter, and it will return a vector. Now, we are taking extra vector to store the answer. Now, we are using a loop from 0 to n, or to the first position to the last position of the input array, and we will mark the corresponding element negative. After that, we will again run a loop and check whether the current element is greater than 0 or not. If our current element is greater than 0, that means we have to simply append the index number. Finally, we have to return the resultant vector. I hope you understood the code. Now let's move on to the time and space complexity analysis of this program. In this program, the time complexity is big O of n because we are using one loop to iterate each of the element, and the space complexity is big O of 1 according to the problem statement because we are using only the constant extra memories to solve this problem. And here we are not considering the extra spaces we are taking to store the answer. So here overall space complexity is big O of 1. I hope you understood the time and space complexity. Thank you everyone for watching this video. We will get back soon with another LeetCode solution.